Start number 7. Straight line graphs. Straight line graphs is basically coordinate geometry. Done this mostly in simple math. And just go through the summary. Length of the line distance formula, gradient, slope, coordinates of midpoint. Do you remember these?
Yeah, I do.
When two lines are parallel and the gradients are equal, m1 is equals to m2. If they are perpendicular, the relation is first is m1, the second is minus 1 over m1. m1 into m2 is equals to minus 1. The equation of straight line is y is equal to mx plus c. Problem solving involving length of line and midpoint. You need to know how to apply the formula for the midpoint and length. Find the, okay, straight away it is just finding the length. So we just apply the distance formula on the given points. I have these two minus 3, 7 and 6 minus 2. So anything is just taken this as second point. Let me take this as second point. So x2 minus x1 whole square plus y2 minus y1 whole square root. So 6 3 is minus 9 and 7 2 is 9. So basically 9 square 81 plus 81 whole square root 162, and we'll end up with same answer. Similarly, midpoint x1 plus x2, y2, y1 plus y2, y2.
So wait, so we got the length of the line, and then afterwards the second part was just like the coordinates of the perpendicular, right? So from the length of the line, how would we like get like the equation for? Oh no, it says midpoint. Okay.
No, that's a separate part. That was just
Yeah.
simple plugin. So like it's already done. So I just do it.
Okay.
For distance, I just swap the points and show that the answer stays the same.
Okay.
The distance between 2 points P and Q is 15, and this A is unknown and distance is given. So we just plug in the formula 7 comma A plus 1 comma 9. So when we do that, we just solve them as A minus B whole square, get an equation and equate it with 15. To get rid of square root, we take square on both sides, and then finally do the midterm breaking of the quadratic equation and get two values of A. The coordinates of the midpoint of the line segment, this and this, are this. Midpoint is already given. So sum of x minus 5 and p half is equals to 2.5. And sum of y is 11 plus q over 2 is equal to minus 6. So mid of x is equal to 2.5, mid of y is equal to minus 6. Then we cross multiply and simplify. The three vertices of parallelogram are already given. Find the midpoint of AC. Now, this is what differentiates it slightly from general math. We need to know the exact geometry of the shape. So it says it's a parallelogram. So roughly, if I would say that this is that parallelogram A, B, C, D, irrespective of whatever the coordinates are. So ABC is given. ABC is given, and he's asking about the midpoint of AC first point. So midpoint of AC is right there. A and C. X plus X over 2. Y plus Y over 2. That's 4 by 2 and 5 by 2. 2 comma 2.5. So mid is 2 comma 2.5. Now D is actually missing. D is actually missing, and it says find the coordinate of D. So here we need to know that in parallelogram, the midpoint of diagonals is actually same.
So perpendicular to 2, comma
No,
2.
it is not perpendicular. This is not 90 degrees.
Oh,
This
okay.
is not 90 degrees, but the midpoint is same. We talk about
Oh,
AC.
yeah.
BD midpoint is same.
So then we just have to plug in the values for B and like try to equate them with what we got for midpoint
Yes.
of AC. Okay.
The coordinates of D are actually x comma y unknown. So 6 plus x over 2, and the mid is already there. Then for y, minus 2 plus y over 2, and mid of y is already there, 2.5. And now we solve for x and y. 6 plus x is equal to 4, x is equals to minus 2. Minus 2 plus y is equal to 5, y is equals to 7. Minus 2 comma 7 are coordinates for D. Find the length of line segment. Try the first one.
So then length is just going to be like the distance between them, right?
Yeah. First one. Simplify and share your answer.
So 3. Because it's 5 minus 2 squared plus 0 minus 0 squared. And the 0 is just 0. And 5 minus 2 is 3 squared, 9 square root 3.
Now, just observe that the difference between 2 and 5 is also 3, and what you've done is also 3. So sometimes when you have like there's no change in y or there's no change in x, we just see, for example, in this case, this was x2, y0, and then it was x5, y0. Y is not changing, so simply the distance is difference between those two x. For example,
Oh, so then yeah, okay.
I'll have like x1 y2, x1 y7. So without formula, the answer would be difference between these two y's because x is already not changing. The distance is just vertical. So if I say this
Okay.
is AB, then AB is equals to 5 in this case. And here we would just plug in to solve. Try this and then we'll move on to the next question. H1.
8.062.
8.062, I'm getting 3.6.
Oh, I just plugged it into the formula, right? So square roots x2 minus x1 squared plus y2 minus y1 squared.
And what do you get when you do x2 minus x1?
X2 minus x1, so it's -1 minus -3.
Yeah.
Oh, so then they add. Okay.
I know. First, that is correct, but it would change the sign.
Yeah,
X2
I just okay. Yeah,
y2
I just
minus
did -1 -3, but it's supposed to be -1 plus 3. Yeah, the sign changes. So then that's just 2. So it'd be 4 plus then the same thing, 5 plus 2. Then yeah, so then it'd be -3. So 9. So 4 plus 9, right?
yeah. That's square root 13.
So 13 square root. So 3.6. Yeah.
In other words, whenever you are plugging this in, because we do have to show complete working, whenever you're solving the question, just see what is the change in x. -3 and -1, the change is 2. And what is the change in y? -2, -3, the change is 3. The difference is 3. So basically we had 2 square plus 3 square whole square root at square root 13. If I would avoid the formula and look at number f, see it says 4 comma 4, definitely I will show the complete working, but if I know the step mentally, I would avoid any mistakes of plus minus.
Yeah,
I can say
anyways, there can't be any anyways negatives when you're actually answering it because it's squared at the end.
yes, yes. Now if you look at the difference, it is
16.
24.
Oh yeah.
Positive 4 and negative 20. The difference is 24.
Yeah.
If you draw this on grid, this is negative 20. This is positive 4. So difference is 24. And then the difference in y is 7. We would definitely show complete working in exam. This is just a tip to avoid any mistake. We get 25. Okay. First was find the length of line segment joining these. Second is calculate the length of side of triangle PQR. Use your answers to determine whether or not the triangle is a right angle triangle. PQR. So definitely if we have to show if it is a right angle or not, there are other ways as well, but the question is restricting us to solve it through distance. Or else we could have checked that gradient of PQ and gradient of QR.
And then gradient of RP.
and yes, then RP. Any two gradients multiplied with each other, if they will give -1, then it is show that they are perpendicular to each other. For now,
Okay.
we go for distance. P is 3, 11. Q is 5, 7, and R is 11, 10. So distance PQ x2 minus x1 whole square plus y2 minus y1 whole square root 2 square 4 square square root 20. I'll leave it as this. And then I'm finding QR x2 minus x1 whole square plus y2 minus y1 whole square 6 square 3 square 36 plus 9 square root 45. And then the third one is PR x2 minus x1 whole square plus y2 minus y1 whole square root 8 square 1 square. Now, without solving, I can see that this is the largest side. So if it is right angle triangle, hypotenuse is equals to hypotenuse square equals base square plus perpendicular square. If it is, it should follow this equation and give left hand side equals right hand side. So longest side squared is equal to square of two smaller sides. Square cancels out with
So
square.
then I'll do, yeah. So 65, 45, yes, it does.
So yes, that is a right angled triangle. Literally. Now there's no restriction that how to prove that it is right angled. But the second last word, isosceles.
Hello? Can you hear me?
Yeah, I can hear you.
Okay. My microphone was
But the second last word definitely restricts us to go for lengths.
So we have to get two of the same length, so we know that's isosceles.
Yeah.
So then do I answer this one?
Sorry.
Do I answer this one?
Yeah, question.
Do I answer this one, right?
Yes, question number 3. Go for working and get two sides equal. Yes, we is to working.
Okay. Yep. So basically, AB and BC are both 2 square root 10, whereas AC is 4 square root 5. So this makes it. Oh, and I have to show that it's right angled, right? So I got that it's isosceles.
Yes, A, B, and B, C, 2 square root 10.
Yeah, and then the AC is 4 square root 5. Then I have to now show that um uh it's gonna be right angled, right? So I just have to plug all the values in to the
Yes.
hypotenuse squared. Okay.
And AC is coming out as longest side, right?
Yep.
4 square root 5 whole square is equal to 2 square root 10 square plus 2 square root 10 square. 40 plus 40 and 4 square root 5 square is 80. So yes, this is a right angle and isosceles. Okay, if we would have to do this question through gradient, coordinates of A is -1, 0, coordinate of B are 1, 6, coordinate of C are 7, 4. Now that we already know that AB and BC are actually perpendicular to each other, I'm just directly going for gradient of these. Gradient of AB is y2 minus y1 over x2 minus x1. 6 over 2, 3. And gradient of BC is y2 minus y1 over x2 minus x1. Minus 2 by 6 is minus 1 by 3. We can clearly see, but we will show the working. M1 into M2 is equals to minus 1. First gradient is 3. Second is minus 1 by 3 equals to minus 1. Minus 1 equals minus 1. So this shows yes, they are perpendicular. Number 4. The distance between points P, which is 10, 2B, point Q, which is B, minus 5. The distance is given PQ is equals to 5 square root 10. Find the two possible values of P. Distance is already given. X2 minus X1 whole square plus Y2 minus Y1 whole square root is equals to 5 square root 10. X2 minus X1 whole square, Y2 minus Y1 whole square root is equals to 5 square root 10. I'm getting rid of the root right here. So that is B minus 10 whole square is A square minus 2AB plus B square. A square minus 2AB plus B square is equal to 5 square is 25 into 10, 250. 5B square plus 125 is equals to 250. 5B square is equal to 250 minus 125. 5B square is equals to 125. B square equals 125 by 5. B square equals 25. Now we go for square root both sides. So we get B is equals to 5 and B is equal to minus 5. Any doubt in this question?
No.
Try number 5. Two possible values of A. Is it working?
Yeah, I'm doing it. So A can either be 5.81 or 0.861.
Getting in decimals.
Yeah. I also have the fraction as well.
If you have the exact fraction, may I know that?
Okay, 10 plus square root 55 over 3, or 10 minus square root 55 over 3.
I was hoping that I'll get in teacher answers and quickly plug them back in and see if the distance is still 5. Let's just quickly check them. Exercise 7.1, question 5. Seven point one and question number 5 is 1 and 3. Seven point one. Question 5 is 1 and 3. Coordinates of P are 6 comma minus 2 and Q are 2a comma a. And the distance between these 2 points is 5. PQ is equals to 5. x2 minus x1 whole square plus y2 minus y1 whole square root. 5 is equals to x2 minus x1 whole square plus y2 minus y1 whole square root. Squaring both sides, 25 is equals to a square minus 2ab plus b square. Now this is actually a plus 2, so a square plus 2ab plus b square.
Oh, it's positive a squared.
Yes.
Oh, I did it negative. Okay. But all my values are the same.
Yeah, 5a square minus 20a and 40. 5a square minus 20a plus 40 minus 25 is equals to 0. 5a square minus 20a plus 15 is equals to 0. Dividing by 5, the whole equation is a square minus 4a plus 3 is equals to 0. Product is 3, a square minus 3a minus a plus 3 is equal to 0, and sum is minus 4. A minus 3 minus 1, a minus 3, a minus 1 into a minus 3 is equals to 0. A is equals to 1 and a is equal to 3. So what I was expecting for a quick check is P was 6 comma minus 2 and Q when A is 1. So 2 1 times 1 comma 2 comma 1. And on the other side, P is again fixed 6 comma minus 2, and if it is 3, 3 to the 6 comma 3. And a quick check, change in this x is 4. Change in this y is 3. So 4 square plus 3 square is 25 and final answer 5. Now see, change in this x is 0 and change in this y is just 5 and 5. So difference is 5, 5. So yes. Question number 6. Find the coordinates of the midpoint of the line segment joining these two. So simply plug and play, trying question number 6, B part. 4 comma 3, 9 comma 11. So midpoint is x1 plus x2 and half of that, y1 plus y2 and half of that. 13 by 2, 14 by 2, 6.5 comma 7. Try the last one, part. 2a comma minus 3b, 4a comma 5b.
3AB.
3A and B. Right. Number 7, we work out A and B. Condition is given, midpoint is given, coordinates of P and Q are given. Are you getting these answers?
Okay, I got the B, -8, and I'm just gonna do the A again real quickly. Yeah, -18. Okay.
Okay, 3 of the vertices of parallelogram are A, B, C, D. Find the midpoint of AC. And this is the nature of the question is exactly the same as we discussed. Do you think you can do that?
Yeah, I'll try. Okay. The same as the one that we did before in the parallelogram.
Yeah.
For A, it's 0, 4.5, and then for B, it's 1, -1.
1, -1. Getting positive 1. Recheck. I'm getting 1 positive 1. See, for D, if you have 1 and negative 1, and B is already 1 and 8. So this is 0 by 2, and change in these two. So sum of these two by 2. This is 7 by 2. We're not getting same. I'm solving for y only. Y plus y by 2 is equal to 4.5. So y plus 8 is equals to 9. Y is equal to 9 minus 8. Y is equal to positive 1.
Oh, okay. So I think I got mixed up with the sign then.
Okay. Question number 9 says the point P is given and is equidistant from A and B.
The same distance both from A and then from B.
Yeah, so first we work out and then we equate them. We can do that in
Okay.
one go as well, but that's definitely going to be a little lengthy. PA is equal to PB.
How would we do it in one go? Like,
Exactly, I'll show you.
okay.
Like one straight line. P is given to K comma K. A is minus 2 comma 4 and B is 7 comma minus 5, and P is equidistant from these 2 points. So that means PA is equals to PB. So distance x2 minus x1 whole square plus y2 minus y1 whole square root is equals to PB x2 minus x1 whole square y2 minus y1 whole square root. Then we go for squaring both sides, get rid of square root, and inside we solve those algebraic expressions. So a square minus 2ab plus b square. A square minus 2ab plus b square. Right hand side, a square minus 2ab plus b square. A square minus 2ab plus b square. Now slowly, this is 4k square, this is 4k square. And I can see k square and k square. I'm collecting all k's on left hand side. This is 8k minus 8k, and on right hand side is 28 and 10 plus 28k minus 10k. And all the numbers on right hand side. 49 is already there, 25 already there, 16 and 4 minus 16 minus 4. 18k is equals to 49 plus 25 minus 16 minus 4 is 54. K is equals to 54 by 18. K is equals to 3. That was in one go. The other would have just have been, so we solve only one hand side and we end up with one answer and then the other, and then just equate them. Number 10 says the triangle ABC and the midpoint of sides AB, BC, and AC are P, Q, and R respectively. Find the coordinates of A, B, C. Okay, that's midpoint, a bit of a lengthy question. Let's just extract the data first. The triangle ABC, midpoints of AB, BC, and AC are these. A, B, C. This is P, 2, 3. This is Q, 3, 5. And this is R, -4, 4. Triangle, the midpoints of sides A, B, B, C, and AC are P, Q, R. 2, 3, 3, 5, and -4, 4. Find the coordinates of A, B, and C. So definitely we're going to make some equations. So let's say this is 1, this is 2, and this is 3. So when I'm talking about A and B, I would say x1 plus x2 over 2 is equal to 2. And y1 plus y2 over 2 is equal to 3. And then for B, C, x2 plus x3 over 2 is equal to 3. And y2 plus y3 over 2 is equal to 5. And the third one, x1 plus x3 over 2 is equal to -4. y1 plus y3 over 2 is equal to 4. Now these are equations for x. I'm picking up these equations and solving for x. This says x1 plus x2 is equals to 4. The next one says x2 plus x3 is equals to 6. The last one says x1 plus x3 is equal to -8. So if I just select this one, x1 is equals to 4 minus x2. So x1 is basically 4 minus x2 plus x3 is equal to -8. Simplifying, minus x2 plus x3 is equal to -12. And now we can solve these two, x2 and x3. So I'm adding these two, x2 plus x3 is equals to 6, solving them simultaneously. When I add them, I get rid of these two. This is 2, x3 is equal to -6. So x3 is equal to -3. x3 is equals to -3. Now when we have x3, I can solve for x2 using the second equation. -3 goes on other side. x2 -3 is equal to 6. So x2 is equals to 9. And when we have x2, I'm using this first equation. 4 minus 9 is -5. x1 is equal to -5. Right? And I'm going for y. Exactly in the same order. Looking at the first one, this
Yeah.
is y1 plus y2 is equals to 3, 2 times 6. And y1 is equals to 6 minus y2. I can see where y1 is and substitute to get 6 minus y2 plus y3 is equals to 4 2 times 8 minus y2 plus y3 is equals to 8 minus 6 is 2. Now look at the third expression with 1, 2. Sorry, the first one was y1 plus y2 is equals to 3. So y1 plus y2 is equals to 6. y1 making that subject is 6 minus y2. Replacing y1, now 2 and 3. And this is 2 and 3. So basically that is y2 plus y3 is equal to 10. y2 plus y3 is equal to 10. So we just add them. We get rid of this. This is 2. y3 is equal to 12. y3 is equal to 6. So y3 is 6. When we have y3, we can solve for y2 and y1. y3 is just 6. I'm using this equation. y1 plus 6 by 2 is equal to 4. 4 2 times 8 minus 6 is 2. y1 is equals to 2. And when y1 is 2, y3 is 6. Where what is left? y2 is left. I'm using this equation. We have y1 as 2 and y2 is unknown. So 2 plus y2 by 2 is equal to 3. 2 plus y2 is equal to 6. y2 is equal to 4. Now just quickly, let's check if we get the same answers. I'm checking for AB midpoint. 9 minus 5 is 4. 4 by 2 is 2. 4 plus 2 is 6. 6 by 2 is 3. Now on right hand side, BC, 9 minus 3 is 6. 6 by 2 is 3. 4 plus 6 is 10. 10 by 2 is 5. AC, minus 5 minus 3 is minus 8. Minus 8 by 2, minus 4. 2 plus 6 is 8. 8 by 2 is 4. Getting correct coordinates of A, B, and C. Okay, 7.2 is about parallel and perpendicular lines. We already know in parallel line M1 is equal to M2. Perpendicular lines M1 multiplied by M2 is equal to minus 1. Now what we did earlier was midpoint and distance. When it was same, we just equated them. So this will be same when we have parallel lines. We would solve for M1 and M2. Definitely we are going to have some unknowns and then equate them. And in perpendicular, we just substitute them in the given formula and solve for the unknowns. 7.2, find the gradient of the line AB for which the following pair of points. That's an easy task. Let's just quickly do B part.
So it just asks us to find the gradient.
Yeah.
Okay.
1, comma, minus 9, 4, comma, 1. So gradient of AB is y2 minus y1 over x2 minus x1. Ten by 3. Question number 2 says write down the gradient of line perpendicular to the line. For now, just we're doing it quickly, otherwise we would show the working. M1 into M2 is equal to minus 1. So the first gradient is 3. The second gradient would be negative 1 by 3. So basically, if I just make M2 the subject of this formula, that is negative 1 over M1. So negative reciprocal. So if I just look at this number, negative 1 by 2, I'll change the sign and reciprocate it. So it would be 2. Then I'll change the sign again and take a reciprocal. This is 4 1 times 4, 1, 5. 5 by 4, this is already 5 by 4. So I'll change the sign and reciprocate. Getting the point?
Yep.
Try the last one.
That's 5 over 2, negative 5 over 2, so that's 2 over 5.
Correct. See question 3. Two vertices of rectangle ABCD are A and B. Find the gradient of CD. Now, they would always follow flow in like clockwise or anti-clockwise direction. So if A, B, C, D, I'm just roughly writing this A, B, C, and which is 3 comma minus 5 and B is 3 comma minus 3. So it says find the gradient of CD. Now we know the geometry of rectangle and we know AB is parallel to CD. So for gradient of CD, it is exactly equal to
It's the
gradient
same.
of AB.
Yep.
Gradient of CD is equals to gradient of AB, which is y2 minus y1 over x2 minus x1 minus 5 plus 3, 3 minus 6 minus 2 over minus 3 is 2 by 3. So gradient of CD is 2 by 3. Then it says find the gradient of BC. Now see, gradient of this side is 2 by 3 and BC is perpendicular to CD. So gradient of BC is negative 1 over 2 by 3. That's negative 3 by 2. Negative reciprocal. 2 by 3. So this is minus 3 by 2 because that's perpendicular to each other. Try number 4. Note down the values and just think how to do it. I'll also follow.
So first we get the first we get the gradient of AB. So that's y2 minus y1 over x2 minus x1. So that's negative 2 plus 5 over 5 plus 1. So then that's 3 over 6. So 1 over 3 is our gradient for AB. And then that's the same gradient for DC. So then afterwards it says BAD is 90 degrees. So then D,
That's right. So we have gradient of CD as 1 by 2 again. So if we just plug in the formula, that is y2 minus y1 over x2 minus x1 equals to 1 by 2. So y minus 1 into 2 is equals to x minus 1. 2y minus 2 is equals to x minus 1. So we're getting an equation 2y minus x is equals to 1. This is one of the equation, and then extra data is AB and BC is perpendicular. Sorry,
AB and DC.
is parallel. BAD, A, B, C, D. So BAD, AB and AD are perpendicular. Gradient of AB is already there, and I'm working for gradient of
AD.
AD. So
Oh, okay.
AD using these 2 points, first and last one. Y2 minus Y1 over X2 minus X1 is Y plus 5 over 5 plus 1. Now we know that AB and AD are perpendicular, and gradient of
Why
AB
is
is
it why is it both Y?
like in the first equation, and now
No, it was Y minus -5 over X minus -1. It's now Y plus 5 or Y plus 1.
but that's
Oh.
X.
So then
So
afterwards we plug this back into,
gradient of AB is already 1 by 2.
yeah,
So gradient of AD must be negative reciprocal. That is already 1 by 2.
the
Negative
-2.
reciprocal is just negative 2. So cross multiply. Y plus 5 is equal to minus 2x minus 2. Y plus 2x is equals to minus 7. Now we solve these two simultaneous equations. The first one
So
is
we can
already 2y
subtract.
minus x is equals to 1. I'm multiplying the second one with 2, or the first one with 2. This is 4y minus 2x is equal to 2, and the second one is y plus 2x is equal to minus 7. 5y, 9y is equals to 9 by 5. 4, 2, and 5.
And then we can plug that back in to get our X.
Yes. So using the same one is 2y minus 1 is equal to x. 9 by 5 minus 1 is equals to x. 18 by 5 minus 5 is equals to x. X is equals to, sorry, that was 1 before we take the LCM. And it's 13 by 5. So coordinates of D are x 13 by 5 and y 9 by 5. Just like to check the answer. 13 by 5, 9 by 5, 2.6, and 1.8. This was 7.2, 4. 7.2 question 4. Minus 3 and minus 1. Minus 3 and minus 1. Quickly check. I was not expecting decimals. AB minus 1 minus 5, B is 5 minus 2, C is 1 comma 1. ABCD, AB is parallel to DC. Gradient of AB, y2 minus y1 is 3, x2 minus x1 is 6. 3 by 6 is 1 by 2. And DC, y2 minus y1, x2 minus x1. They are parallel, we just equate them. Y minus 1 to 2y minus 2 is equal to x minus 1. X comes there, negative x, 2 goes there, 2 minus 1 is 1. This equation is correct. And then AB is parallel to DC. Done already done. Angle PAD is 90. So BA and AD are perpendicular. BA gradient is already there. AB or BA is 1 by 2. And AD y2 minus y1 is y plus 5 over x2 minus x1 is x plus 1. And if it is perpendicular to AB, AB is 1 by 2, negative reciprocal is minus 2. Minus 2x minus 2. Y plus 5. Y plus 2 is equals to minus 7. Equations are correct. So if I just multiply this equation with 2 is 2, 2 times 4, minus 2 and 2. The other one was, oh my god. See, this was negative 7. So this is negative 7.
It was supposed to be positive?
No, I just copied it. Like
Oh,
I
okay.
forgot to copy the negative sign. Everything was correct. The concept is correct. Just copying the negative sign. So now 4 and y 5y equal to minus 5. So y is equals to minus 1. Y minus 1. And now for x, 2y minus x is equals to 1. 2y minus 1 is equals to x. So 2 into minus 1 is equal to x. Minus 2 minus 1 is x. And x is minus 3. Minus 3 comma minus 1. Coordinates of D. Now this is correct. So formulas are definitely important. What we are going for, distance or midpoint or gradient, and then the concept of the shape. For midpoints and the concept of parallel perpendicular for the gradients.
Okay.
Do try some of the missed questions for practice and these remaining questions.
Okay.
And we'll move on to the next concept in our next class. Anything you would like to ask?
No.